A new discovery may help answer the age-old question of whether or not we are alone in the universe. Today, people in the New York metro area are reporting a growing number of drone sightings. This heightened curiosity about the skies might just reflect a larger mystery, the search for extraterrestrial life. As humanity's gaze turns outward, a breakthrough may lie in the icy depths of Neptune's moon, Triton. For the first time, researchers are studying this enigmatic moon using the James Webb Space Telescope, an incredible tool that has opened up new possibilities in our exploration of the cosmos. Webb's ability to observe infrared light, something invisible to the human eye, sets it apart from previous telescopes. This capability allows scientists to examine Triton in greater detail than ever before. Webb's observations might reveal hidden aspects of the moon, such as the composition of its surface, the nature of its atmosphere, and even faint hints of a buried ocean that could harbor secrets about the potential for life. But the big question is life possible on Triton? To answer this, we need to understand its surface and atmosphere. Can Webb capture the surface of Triton in detail? What materials make up its icy shell? And, more intriguingly, could an ocean lurk beneath the frozen exterior? These are some of the puzzles we're aiming to solve through Webb's observations. As we dive deeper into this exploration, we'll get closer to uncovering whether Triton could one day reveal signs of life, or whether it's just another frozen world in the depths of space. Triton is Neptune's largest moon, and it's as much a mystery as it is a fascinating object in our cosmic backyard. It reflects a significant portion of the sunlight that strikes it, but is encased in a layer of frozen nitrogen that makes it appear quite cold and distant. This unique environment makes Triton a key object of study in our search for life beyond Earth. Astronomers have always been intrigued by Triton's mysterious nature, but with the launch of the James Webb Space Telescope, a new chapter has begun in our understanding of this moon. Webb's advanced technology allows scientists to peer through the haze surrounding Triton, revealing more than we've ever seen before. Imagine Webb as our cosmic detective, with the ability to see things in a completely different way. Instead of relying on visible light, Webb looks at infrared wavelengths, which allows it to observe cooler and more distant objects that would otherwise remain hidden. Think of this as if Webb has a superpower that enables it to see beyond what the human eye can perceive. Using infrared light, Webb can map the composition of Triton's surface, helping to identify different types of ice, gases, and even potential signs of past geological activity. While Webb cannot photograph the surface in the same way a rover might, its ability to detect infrared radiation makes it possible to understand Triton's temperature, surface conditions, and atmospheric dynamics, all of which are key to understanding whether life could exist on this distant moon. Webb's infrared vision is like a high-tech artist with a palette of colors that represent various chemical signatures. Each color tells a story, whether it's frozen methane, nitrogen, or other substances present on Triton's surface. By analyzing these colors, scientists can learn more about the moon's history and evolution. For instance, these colors may hint at past comet impacts, collisions, or even ancient volcanic eruptions that have shaped Triton's surface. Webb is not just mapping the present, it's peering back in time, uncovering clues about how Triton may have evolved and whether its surface has ever been disturbed by significant events like cryovolcanic eruptions, similar to the icy volcanoes found on other moons like Europa and Enceladus. The real mystery, however, may be hidden beneath Triton's frozen surface. Scientists believe that Triton might harbor a subsurface ocean, protected by the moon's icy crust. This ocean could be kept warm by the gravitational tug-of-war between Neptune and Triton, which may generate enough heat to support liquid water below. Webb isn't able to see this ocean directly, but it can look for clues that suggest its presence. For example, if Webb detects an unexpected warm spot on Triton's surface, where there shouldn't be one, it could be a sign that water is rising from below, bubbling up through the ice. This would be a huge breakthrough in understanding Triton's potential for harboring life, as liquid water is one of the essential ingredients for life as we know it. Beyond the possibility of water, Webb's observations might also uncover signs of ongoing geological activity beneath Triton's surface. It's not just about the ocean. Webb is also looking for signs of cryovolcanism, or cold volcanoes, where icy materials like water and ammonia erupt instead of molten rock. This could indicate that Triton's interior is still active, with processes that might make the Moon more geologically dynamic than we previously thought. Webb's findings could have broader implications as well. For example, studying Triton may help answer questions about the origins of Plutoids and other Kuiper Belt objects, KBOs. Where did they come from? Did they form near Neptune, or were they pulled in from farther out in the solar system? Understanding Triton's composition and geological activity could provide key insights into the formation and migration of these icy bodies. Triton's potential for harboring life goes beyond just the Moon itself. If Webb finds evidence of a subsurface ocean on Triton, it strengthens the possibility that other icy moons in the outer solar system, like Europa and Enceladus, could also have habitable environments. By examining Triton's potential ocean and its composition, we could gain insights into the conditions needed for life to exist in these distant, frigid regions. Moreover, Webb could uncover important clues about the presence of organic molecules on Triton. These molecules could be crucial for understanding how life might arise on other cold worlds. One of the most exciting possibilities is the detection of organic molecules in cryovolcanic plumes. If Webb detects signs of methane, ammonia, or other organic materials being released from beneath Triton's icy shell, it could point to the presence of primordial chemicals needed for life. This would make Triton one of the most intriguing objects in the solar system, as it could offer a glimpse into the kind of chemistry that could support life in cold, distant environments. Despite Webb's incredible potential, there are challenges ahead. Triton is extremely far from Earth, about 2.8 billion miles away, which means that Webb's observations will be limited in resolution. Long exposure times are needed to capture the faint light reflected by Triton, and even with these efforts, sudden atmospheric changes or other fast-moving phenomena might be difficult to detect. However, Webb is just the beginning. Future missions to Triton, utilizing Webb's findings, could provide us with a clearer and more detailed picture of this distant world. Future missions may involve sending an orbiter specifically designed to study Triton's surface, atmosphere, and possible subsurface features. These missions could provide the most comprehensive view of Triton, with high-resolution imaging, in-depth atmospheric studies, and possibly even the detection of plumes or other geological signs. A lander could further enhance our knowledge by studying the surface chemistry in situ, collecting samples from any eruptive plumes, or even exploring the icy landscape directly. The James Webb Space Telescope is revealing new possibilities for understanding Triton and other distant moons. Instruments like the Near-Infrared Camera, NIRCam, and the Mid-Infrared Instrument, MIRI, are key to these breakthroughs. NIRCam can penetrate the haze surrounding Triton, mapping the surface composition and identifying chemicals like methane and nitrogen. MIRI's ability to observe deeper into Triton's atmosphere might detect gases like carbon monoxide and methane, potentially pointing to cryovolcanic activity. Although the journey to Neptune and Triton is challenging, future missions, powered by Webb's discoveries, will continue to push the boundaries of space exploration. The distance to Triton, combined with the weak sunlight at Neptune's location, means that space missions will need to use innovative power sources and propulsion methods, like nuclear power or gravity assists. At the same time, we must be mindful of the need to protect Triton from contamination by Earth microbes, ensuring that we explore responsibly while searching for signs of life. Triton's mysteries are far from solved, but with the help of the James Webb Space Telescope, we are closer than ever to uncovering the secrets of this fascinating moon.